Hello everyone, this is the Unit 9 review by topic in Algebra 1, and we are going to talk about topic number 1, standard form and degree of a polynomial. So number 1 that says determine the degree of the polynomial, and just remember all you have to do is just add up all of the exponents, all right? So that's all you have to do. So it is 3 plus 5. 3 plus 5 is the 8th degree. And then 6 plus 1 would be the 7th degree. All of the exponents of the variables, I should say. And then this is 3 plus 1 plus 1. Because this is a 1 and this is a 1. So we have the 5th degree here. Now, determine the degree of the polynomials below, a little bit different than monomials and polynomials. The polynomials, you just take the largest exponent. And I just add the exponents of all the variables for the monomials and determine the degree of the polynomial, largest exponent. So the largest exponent is the 3 right here. And so this would be the 3rd degree. The largest exponent would be the 4, so this is the 4th degree. The largest exponent would be the 5, and that would be the 5th degree. Whenever we're talking about standard form, you're writing the largest exponent first, followed by the next largest, and followed by the next largest, and then finally the constant. So this one would be first. That would be 6x to the 5th, because it has to the 5th power. This would be second, because that would be third. That would be to the 3rd power, the next lowest exponent, and this would be third. That would be 4x. And then this is the constant. That would be minus 8. That is standard form. This one would be first, because that has the largest exponent, and take the sign of the number with it. This would be second. That's a negative x to the 6th. This would be third. That would be plus x. And then this would be 4th. That is the constant. That is a plus 12. So this would be the 5th degree with a leading coefficient of 6. This would be the 7th degree with a leading coefficient of negative 5. All right, so I put down the 5th degree with a leading coefficient of 6 for A. And then, by the way, this is the constant. And this is the constant for that. This is the 7th degree with a leading coefficient of negative 5. What is the degree of the polynomial listed here? First off, it's not in standard form. You don't have to write it in standard form. You just have to go to the largest exponent and say it's in the 3rd degree. But if you were writing this in standard form, it would be 7x to the 3rd minus 3x squared plus 5x minus 1. That's standard form. So this has a leading coefficient of 7 and a constant of negative 1. Which statement is correct about this polynomial? It's a 3rd degree polynomial. It is not. It is a 2nd degree polynomial, so that's out. It is a 3rd degree polynomial? No. 2nd degree polynomial with a constant term of 2. It does not have a constant term of 2. 2nd degree polynomial with a leading coefficient of 3. Here's the leading coefficient of 3. This is the correct answer. This would be correct. C would be correct if it said -2. It does not. It says +2. So topic number 2, adding and subtracting polynomials. So you just have to make sure that you are reading correctly here. This is 3 times the sum of this and this. So what I'm going to do is I'm just going to rewrite. Since we're talking about the sum, that's addition. That's 5x squared minus x plus 3, no parentheses needed, -8x squared plus x minus 6. Then I'm going to just combine like terms. So I have the 5x squared minus 8x squared, and the 5x squared minus 8x squared is -3x squared. Then I'm going to go -x and +x. They cancel. All right, so I am boxing out this and this. And then these cancel. And then you have -3 minus 6. So that is a -3. So not terrible. But it says 3 times the sum. So I'm going to go ahead and put that in parentheses and put the 3 out in front. Now I am going to do distributive property. And 3 times -3x squared is -9x squared. And then 3 times -3 is -9. And that is your answer right there. Write an expression that is equivalent to this. I'm just going to go ahead and do distributive property right here. 6 times x squared is 6x squared. 6 times -3 is -18. And then I'm going to distribute this negative throughout. When you distribute a negative, it changes all the signs of everything inside the parentheses. And then we're going to combine like terms. So we have the positive 6x squared minus x squared is 5x squared. And then we have the plus 8x squared, 8x. And then -18 minus 12 is -30. And that's your final answer. Write an expression that's equivalent to this. Then we're going to do distributive property again. This is 3x squared minus 12 plus, and then we'll do distributive property. That is 4x squared. And then 4x times -7 is -28x. Don't forget about the x there. So this is 3x squared plus 4x squared is 7x squared. Then you have -28x, and you have minus 12. And that is your final answer. Number 4, if a equals 2x squared minus 8 and b equals 6 minus x, then a minus 3b equals, okay, so first off, here's my a. I'm going to put that a down. And then minus, and 3 times b. That's the way I'm going to put it down. So I'm going to bring down this 2x squared minus 8, and I'm going to distribute here, which is -3 times 6 is -18, and -3 times -x is positive 3x. Now I have 2x squared, just combine like terms, plus 3x. And I am going to have a minus 26. this is being subtracted from this, right? So that means 6x squared comes first. It's being subtracted from this. So we're just going to put 3x minus 4 times 3x minus 4. So I'm going to do just some distributive property here. So we're going to have 3x times 3x is 9x squared. Then 3x times negative 4, which is negative 12x. This is also a negative 12x. This right here is a positive 16. So this is 6x squared. And then this is minus, and it's the whole thing that is subtracted. You have to put it in parentheses because that minus sign needs to be distributed to everything inside that parentheses. So I'm just going to put this 6x squared minus, and I'm going to put 9x squared because I didn't combine the like terms, negative 24x plus 16. And the final answer would be 6x. Let me just put it over here. My final answer would be 6x squared. Nope. Let me extend it. 6x squared minus 9x squared plus 24x. I'm distributing the negative, and it changes all the signs inside the parentheses. So we have a negative 3x squared plus 24x minus 16 as my final answer. And I did not put the x there. A little bit tricky. Final answer. Topic number 3, what is the product? We're talking about product, we're talking about multiplication. So the product is 4x. I'm going to set it up in parentheses when we're distributing, so we could distribute. When we're multiplying, in parentheses. So we're going to have 4x times 5x squared. So that's 20x to the third. Then we have 4x times negative 2x, that's negative 8x squared. And then there's 4x times 4, and that's plus 16x. 7 times 5x, that's 35x squared. 7 times negative 2x, that's negative 14x. And then 7 times 4, that's 28. So now we have only one with the third power. And then we have negative 8 squared plus 35 squared, which is 27 squared. And then we have 16x minus 14x, that's plus 2x. And then we have 28. And that is your answer right there. The total area, what is the total area? An area is, the area formula is area equals length times width. So we're just going to, all I want you to do is to multiply the two binomials. So we have 6x times 3x, which is 18x squared. 6x times negative 4. 6x times negative 4 is negative 24x. Then we have negative 7 times 3, and then we have negative 7 times negative 4. So negative 7 times 3x is negative 21x, and then negative 7 times negative 4 is positive 28. So we have 18x squared. We're going to combine like terms in the middle. And then we have negative 45x and then plus 28. That is your final answer. So all you have to do for the next one, number 3, is multiply the following expressions. This is a little bit easier here. All right, so this one is, again, distributive property, and you have 6x squared minus 9x, and then minus 150. And then you're done. Anytime that you have, you could do pretty much anything that you want here. You could multiply the 2 binomials first, or you could just multiply the 6. Like I said, I'm just going to multiply the 2 binomials first because it's really what I know how to do. X times, I know how to do, like it would be okay if you just multiplied the 6 first, or the 2 binomials. And I'm going to do the 2 binomials. So x times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. And then 3 times negative 5 is negative 15. So I'm just going to put this all in to combine like terms here, which is this. And then I'm going to multiply it by 6. 6 times x squared is 6x squared. 6 times negative 2x is negative 12x. And then 6 times negative 15 is negative 90. And that would be your final answer. Now I'm just going to go ahead and distribute the 5x to everything inside the parentheses. Remember, the 5x does not get multiplied to anything outside like the negative 110. So we have 5x squared, 5x times x, and then 5x times negative 3 is negative 15x minus 110. And then that is your answer right there. All right, so I'm just going to do this again where I'm just going to multiply the binomials. X times 3x is 3x squared. X times 4 is 4x. Negative 9 times 3x is negative 27x. And this is negative 36. So I have 3x squared on minus 23x and minus 36. Remember, I have to remember to multiply the x now to distribute. And this is what I'm doing. X times 3x squared is 3x to the third. X times negative 23x is negative 23x squared. And then minus 36x. Final answer. The product of these two, remember, you just have to rewrite it. You need some space. And there we go. X times x, x squared, x to the third. X times negative 3 is negative 3x. 3x times x is positive 3x squared. And 3x times negative 3 is negative 9x. Then we just do 9 times x, which is positive 9x. 9 times negative 3 is negative 27. So then we have x to the third, then the squared, then the squared cancels each other out, negative 3x squared and positive 3x squared, that cancels each other out, and then negative 9 and the negative 9x and the positive 9x cancel each other out, everything cancels each other out, except for the minus 27, and we have that at the end like this. Perfect. Topic number 4, the last topic, when factored completely. Remember, factoring completely means that there is more than one step. Don't stop after a step. So what I usually do, I look for the GCF first. If there is no GCF, then I have to go and try to factor something else, maybe two binomials or something like that. But I see a GCF here. I see an X. X is the GCF. So I'm going to take out the X. So inside, X times 1 equals X to the third, X to the second. X times X to the second equals X to the third. X times what equals negative 8X squared, negative 8X. So just remember, you could, if you want to, divide each term by the greatest common factor. So if you're dividing X on each side, on all of the terms, and you could get these answers inside parentheses. It's not the way that I do it, but I do it like in distributive property in reverse. I ask myself, what times X will equal negative 20X? Negative 20. And when I do distributive property in my head, everything should be equal. X times X to the X squared equals X to the third. X times negative 8X equals negative 8X squared. X times negative 20 is equal to negative 20X. So now we have a trinomial inside here. This is a trinomial. So I'm going to break that up into two binomials. And I'm going to look for a number that multiplies to 20 and that adds to 8. So 1 and 20. By the way, this is X and X. If I multiply to a negative, I know that I have to multiply, it has to be a positive and a negative. So 1 and 20 cannot make 8. 10 and 2, yes, that could make 8. The 10 has to be the negative. The 2 has to be the positive. Then I just go 2 minus 10. That's negative 8. 2 times negative 10 is negative 20. That is factored completely. So going on to the next one, the expression 64x squared minus 49. So I'm going to take a look and say, okay, I'm going to look at the greatest common factor, but before I do the greatest common factor, I notice that 64 and 49, both of them are perfect squares. So if they are perfect squares, and this is a minus sign, that means we can have the difference of squares. Right off the bat. The difference of squares. Let me get that out of there. So that means I get set up two binomials. And what times what equals 64? That's 8x and 8x. Because 8x times 8x equals 64x squared. Then I have the difference of squares, minus and a plus. What times what equals 49? And that is my final answer. Difference of squares. They're perfect squares. As soon as you see two perfect squares, you know you could jump to it. Number 3, an expression that is equivalent to this. Okay, so now I'm going to look and I'm going to say, okay, I see maybe that I could take out the greatest common factor. So what is the greatest number that goes into 12 and 75? 3 is the greatest number. So now I'm going to put, okay, I'm going to divide this by 3. Divide this by 3. So 3 times what equals 12x squared? 3 times 4 x squared minus 3 times what? 25 equals 75. So now, do you see this in the middle? 4 and 25 are perfect squares. Difference of squares. All right, so we have 3, and we're going to set up 2 binomials for the difference of squares. So what times what equals 4x squared? 2x times 2x. This is a plus, this is a minus. What times what equals negative 25? That is it. That is your final answer. And again, 9. I'm looking for greatest common factor first. But the 9 and the 100, they're perfect squares. If they are perfect squares, you have the difference of squares. If there's a subtraction sign in the middle, and there is. So now this is going to set up into 2 binomials. What times what equals 9m to the 9m squared? Positive 3m and 3m. That's 9m squared. Then you have a positive and a negative. The difference of squares. What times what equals 100? 10 times 10. You are finished. Find the GCF. That's all you need to do is find the greatest common factor. You do not have to factor any of this. So the greatest common factor is what goes into both numbers. What's the largest number that goes into both? The greatest common factor is 9 and x to the 5th. So you take out the smallest exponent because x to the 5th goes into x to the 5th and x to the 5th goes into x to the 8th. If you wanted to go a little bit further, then you would put the greatest common factor outside the parentheses. 9x to the 5th times what equals 9x to the 8th. You would just do x to the 3rd. And then 9x to the 5th times what equals 36x to the 5th. That would be 4. And that's basically it. All right, this is extra. This is not needed. Okay. All right, when factored to completely, the expression is x to the 4th minus 16 is equivalent to. So that means 2 steps. So we're going to factor this right into 2 binomials, x squared times x squared. Then the difference of squares is happening there. What times what equals 16. So that's 4 times 4. So that means this one is okay, but this one could be broken down further. So I'm going to put this binomial down here and then set up a second pair of binomials. Because this is x times x, we're going to break this up. X plus x minus what times what equals 4. That's a perfect square. And that's the difference of squares. 4 is a perfect square. 16 is a perfect square. So I'm just going to put perfect and perfect. That's why if you know your perfect squares, this will be a little bit easier for you. If not, then it's a little bit more difficult. All right, so write an expression equivalent to this. So right now I am looking at this and saying x to the 4th minus 8x squared plus 16. They do not have an x. They do not have a a greatest common factor, okay? So they don't have a greatest common factor. I'm going to try to break this, since this is a trinomial, the only other thing that I'm going to try to do is to break it into two binomials. And I know that since it's x to the fourth, it's x squared times x squared. Now I have to look for a numbers that multiply to 16 and that add to 8. Let's see if this works. 1 and 16, 2 and 8, that's not good. It has to multiply to a positive, but it has to add to a negative, so that means it's negative, negative. It wouldn't be positive, positive, only because if it's positive, positive, then that would be a positive 8 squared. All right, it would be all positives. Since that's negative, it would definitely have to be negative times a negative to make that positive 16. So now, does 3 go into 16? No, it doesn't. Does 4 go into 16? Yes, 4 times 4 equals 16, and you can make 8 out of that. So if you want to check it, negative 4 times negative 4 equals 16. Negative 4 plus negative 4 equals negative 8. Look at this. Both of them, the difference of squares. Difference of squares. Second step. Difference of squares. Right here. So now we're going to break this up into a binomial, two binomials. And we're breaking this up to two binomials. X, let's see, plus minus 2 times 2 equals negative 4. This one, same thing. Plus minus 2 times 2. That is your answer, and that is factored completely. All right, factor the expressions. 49x squared minus 400. I see something here. Two perfect squares. 49 and 400 are perfect squares. So I'm going to break this into two binomials. 7x, 7 times 7 equals 49x squared. Minus and plus, difference of squares. 20 and 20. And that's it. Difference of squares. Okay, number 9, the expression x to the 8th minus 121. 121, perfect square. Difference of squares. All right, here we go. So we're going to have two binomials. This is x to the 4th times x to the 4th because that's x to the 8th. Then minus and plus, or plus and minus. What times what equals 121, and that is 11 times 11. That is the end of that answer. You don't have to go any further. Okay, when factored completely, this, let me just do this by hand. I see greatest common factor here. So I'm going to go GCF. And look at my choices. You see how it has negative x on the outside? Yep, that's what I'm going to take out, negative x. So if I take out a negative x as the greatest common factor, let me move this down a little bit. And I go ahead and divide. What times negative x will equal negative x to the third. It's x squared. What times negative x will equal positive 10x squared, which is 10x, negative 10x. Negative x times negative 10x is positive 10x squared. Negative x times what will equal 24, a positive 24, so that has to be negative as well, and 24. Negative x times negative 24 will equal positive 24x. Now, you see this trinomial. I am going to factor it into two binomials. There's going to be an x here and an x here. Since it's a negative that I have to multiply to, I have to get a positive and a negative. So, it has to be positive, negative. Look, positive, negative, negative, negative. That's out. Positive, negative, negative, positive. Okay. So, 24, I have to multiply to 24 and add to 10. 1 and 24, no good. 2 and 12, yes. It has to multiply to a positive, negative 24 and add to a negative 10. So if I put the negative 12, if I put the 12 here and the 2 here, that's negative 2 minus 12 is negative 10. 2 times negative 12 is negative 24. This is your answer, so C is your answer. All right. Again, you could take your calculator and just put that into Y1, put this into Y1, and then put these into Y2 and match up the graphs. That's all you have to do. Okay, that was a quick review by topic. If you know what to do, just remember, when you're factoring completely, it's more than one step. You're always going to go on to another step. Usually, when you factor completely, that means that you're taking out a greatest common factor, like this one, and then you have a trinomial in the middle, or you have something like the difference of squares in the middle in parentheses, and you have to factor that out, just like I did here. Just like I did right over here as far as this goes, factoring completely. You factor it once, then you factor it again. And then you will get your final answer. When it says factor completely, this is the same thing. Factor completely, 2 steps. X squared times x squared is x to the 4th. 4 times negative 4 is negative 16. Then you have the difference of squares on the right-hand side with the x squared minus 4. Just remember the perfect squares. You have to remember the perfect squares because every time that they give you something like this, like number 8, it's 49x squared minus 400. It doesn't look like the difference of squares, but both of them are perfect squares, 49 and 400. You recognize that. That means you know what times what equals that 49. You know what times what equals that negative 400. And that is it. Hopefully that helped, and thank you for watching. See you next time.